Already learned how to, so we learned how to factor trinomials in this form, simple trinomials, non-simple trinomials. We reviewed those yesterday. Back to Math 10, difference of squares, back to Math 10. So we might need to use any of those methods in order to solve by factoring. So the first three here are some more challenging ones. So these are kind of your warm-up of factoring. Okay? These, I don't want you to expand out. So I want you to factor as much as possible, not by expanding first. Even though the first one and probably the second one you could do if you did expand out, try not to. Use the method of, in this case, it would be a simple trinomial because the coefficient is 1. This would be a non-simple trinomial because the coefficient is 3. And this is a difference of squares. Okay? So there's one of each. So you do that right now. All right, so a big thing to look at, the brackets, are they exactly the same? If they are, is it squared, exponent 1, and constant? So then it's that simple trinomial. Two numbers that multiply to negative 48, add to negative 2, would be negative 8 and 6. Keep it in brackets and then collect like terms. And always check those brackets. Can you factor again? Okay, in this case you can't. Okay, so the next is, can't divide anything out. The brackets are the same, squared, degree 1, exponent 1, and constant. So now I'm looking for two numbers that multiply to 15, add to negative 8. Okay, and that's going to be my outside and my inside, the way that I like to do it. Okay, so I'm going to have 3 times that bracket in one of them. Just the bracket, start in the other. 3 is a prime number, so the only choice for the first values is 3 and 1. And then to get my negative 5 and negative 3, this outside would have to be a minus 1 to get the negative 3, and the inside would have to be a minus 5. So then you can get rid of the big brackets, or the little brackets inside, change the big ones to small ones. And that's going to be 6x plus 16, 2x plus 6, and check those brackets. Okay? You can factor both of them again. So 2 is common, 3x plus 8. 2 is common, x plus 3. And always show those monomials out front. Okay, so taking a look here, the brackets are not the same, so you can't common factor them. So take a look at the exponent on the brackets. They're both exponent 2, so they're perfect squares. And any constants, make sure that they're perfect squares. So 9 is. If it wasn't, then you couldn't factor. Also, make sure it's a subtractive. So this is a difference of squares. The root of the first term here is 3 times x minus 2. Okay. Then the root of the second term is 3y minus 5. Actually, I'm going to write this down below because obviously it's stuck in here. So this bracket would be 3y minus 5. Would be 3y minus 5. One has a plus, one has a minus. Okay. Then there's brackets within the big brackets. So you've got to expand out. So that's going to be 3x minus 6 plus 3y minus 5. And 3x minus 6 minus 3y plus 5. And then there are some like terms to collect. So this would be, I'd put the x term, then the y term, then the constant. X term, then the y term, and then the constant. Okay. The only way to check these ones, where there's brackets with different variables, is to expand the original and expand your factors. So that's the only way to check. You can't actually go from there to there. Hard to do that. Right? So for another way, rather than redoing the question again, if we expand both out, check that they're the same. Okay, so notice that these were just expressions. So equations have an equal sign in them. Expressions don't have an equal sign. Okay, in the question. We put an equal sign underneath in each row, okay, to state what it's equal to. Those are just expressions. Now we're going to use factoring to solve equations. Okay. All right, so says a quadratic equation is an equation that can be expressed in the form ax squared plus bx plus c equals 0. When an equation is written so that one side of the equation is 0, okay, we can use factoring and the zero product property to solve it, if it can be factored, okay. Now what's the zero product property? That basically means if you're multiplying two things together, or 3 or 4 or whatever, and the result is 0. So if you're told that you are multiplying m and n together and you get 0, right, that's given to you, then that means that either m is 0 or n is 0 or both of them, right? 5 times 0 is 0. 0 times 10 is 0. 0 times 0 is 0. Okay? That's the zero product property. So if we can get a quadratic equation down to two factors, higher degree, we're going to do higher degree in next week, get it down to, or actually maybe it's later this week, get it down to however many factors, then we can solve each factor equal to 0. Okay? So this is back to x-intercepts. So x-intercepts of that function, well, that means you're trying to find, so x-intercepts are when y is 0. So you put 0 in for y. So now you're solving that equation. So really, finding x-intercepts is an application of solving equations. Right? So you put 0 in there. Factor it if you can. Probably you can, since we're in a factoring. That's the point of this lesson. So what are two numbers that multiply to negative 16 and add to negative 6? That's what you're asking yourself. Yeah, negative 8 and 2. Good. Okay, it doesn't matter which factor is first. Okay. So now, in order to be equal to 0, that means each factor has to be equal to 0. You can show them separately, but you should be at the point where you don't have to. So you should be able to look at this now and say x equals negative 2 and positive 8. Okay. And you can quickly check. If I put negative 2 in there, I would get negative 10 times 0. Well, negative 10 times 0 is 0. That's good. I put 8 in, 8 minus 8 is 0, 0 times 10 is 0. Okay, 2 solutions. You're never going to get more solutions than the degree. So if the degree is 2, quadratic, maximum you'll get are 2 solutions. Okay, if it's degree 3, the maximum will be 3 solutions. That's going to tell you. You might have less, depending if that was a quadratic that just touched once, or didn't touch at all, there would be none. Okay, so now here, based on this question, those are my solutions. I'd say, so therefore, x-intercepts are negative 2, If it said the coordinates of the x-intercepts, then you put in negative 2 comma 0 in brackets or 8 comma 0. But if it says the x-intercepts, it's just those values. Okay. So solve by factoring. Notice how there are no y's. You're just solving. Okay, so you want to get one side equal to 0. Here there's terms on both sides. So I always like to keep the x term being positive. So I'm going to bring everything to the left. So by subtracting 5x and subtracting 1, and then factor. Okay, so it's a non-simple trinomial. So I want two numbers that multiply to 4 and add to negative 5. So always when it's 1 away, it's going to be 1 in itself, both negative in this case. Okay, but those are not the values that go in there. I set up my first terms. Then in order to get negative 4x, I'd have to multiply 2x by negative 2 for the outside terms. And then negative 1 or subtract 1 is the constant on the inside. So then your solutions, remember opposite sign of the constant, divide by the coefficient. Opposite sign. And so we often put those in the squiggly brackets for the solution. Okay. If you wanted to check, okay, so to check this, I'd probably go from the second version, so that's when you're looking for your x-intercepts, because remember, this is the corresponding function. You're graphing y equals, and then 2x squared minus 5x plus 2, and let me see, I'm going to do a standard screen. I also graphed y equals 0, so I'm looking for those x-intercepts, or the intersection of these two graphs. So second phase intercept, enter, 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 is 0.5, which is 1/2. Then you can do the same intercept closer to the other one, and you get 2. Okay, so you can verify using your calculator. Okay, next one. This is what sometimes you see. Okay, that's not completely correct. So here, divided by x. We don't like dividing by x. Okay? So if at all possible, try not to do that because you're going to miss the solution. If I were to graph this, say the left side and the right side. So without even doing any algebra, standard screen, I'll put standard. How many times do those intersect? Twice. By doing that, I only got one. Okay, so I missed one because I divided by x. I kind of got rid of that particular solution, which is going to be x equals 0. So here's what you want to do, is get everything to one side, just like we did there. So no different. Okay, factoring. This one's easy. It's just a common factor. Okay. So then, two factors here. X equals 0. Sometimes students forget about it, but it's x equals 0, because 0 times this will be 0, or vice versa. And then 5/3. So by dividing by x, you lost the solution of x equals 0. So those are your two solutions. Next one, a lot of algebra to do, but do that and get one side equal to 0. And then D, same thing. I would get rid of the fractions. So think about what you did back in rational equations last semester. Okay, so I'll give you a few minutes to work on C and D. Remember, when you square a binomial, you get 3 terms. Some of you are still forgetting that. Don't let my hair get more gray, right? Every time someone does that, I get another gray hair. Then I'm going to get it colored. Cost me money. Okay, so we'll always deal with the brackets first. And then get rid of the brackets. Then collect like terms and get the 4 over to the left. And then after that, it's a simple trinomial. So x is to start two numbers that multiply to -12, add to 1. Means they have to be 1 apart, right? So 4 and 3, where 4 is positive and 3 is negative. Okay, for these equations so far, there's nothing, we haven't had any rational equations yet, where there's variables in the denominator. Remember, we did learn that in 10 IB. That we had to check our solutions with our non-permissible values. Make sure that there weren't any non-permissible values that were solutions. These ones, there's no variables in the denominator, so you don't have to do that check. Okay. Here, so this one, because of the fractions in terms of factoring, like it'd be hard right now, I find. So I'm going to multiply through, this is like back in Math 10 with rationals, multiply through by the lowest common denominator, which is 10 in this case. So 40 divided by 5 is 8x squared. The distribute the 10. Okay, and then get everything to one side. Now it's a non-simple trinomial, so factor that. Two numbers that multiplied in negative 24 and add negative 10. So one positive, one negative. So you might think negative 6 and negative 4, but that would multiply to positive 24. So 12 and 2 work. This would be negative 12 and 2. Okay. Now, we have to then think, when I've been doing this by trial and error, the coefficient of the x squared term has always been a prime number. Now it's not a prime number. So I also have to consider what's going to go in there. So obviously they both have x terms, but my outside and my inside have to multiply to these values. So this tells me right away that I likely want to have 2x in one of them and 4x in the other, because of that 2 there, and this is also 4. If I put 8 in one of them, I couldn't get these values. Okay, so the only other choice between 8 and 1 is 4 and 2. So now, on my outside, I would have a plus 1. On my inside, I would have a minus 3. Okay, so turn over to the next page. We're going to do a couple of application questions. Actually, the first one isn't really an application. It's just working backwards from what we've been doing. So it says, write a quadratic equation with those roots. So now, the roots are there. We have to work backwards and show it in standard form. So here are my roots. What did I do to get back to the beginning? Well, I would have to put them in brackets, opposite sign, okay, for the constants. Then I would expand it out, okay, to get it back into that standard form. Here, 3 over 2, remember that's going to be opposite sign of the numerator. Coefficient of x is the denominator. Opposite sign of the numerator, coefficient of x is of the denominator. Okay, then expand that out. So that's what I do in this one. It's quadratic, so you know you have 2 sets of brackets equal to 0. So the first one, anytime it's an integer, it's just going to be x. That's going to be x plus 2. If it's a fraction, then the denominator is the coefficient of x, the numerator is the constant, and it's the opposite sign. And then expand that out. And that's it. That's your check. It says A, we want A to be greater than 0. A is the coefficient of x squared. It's greater than 0. Okay. If it wasn't, just divide everything by negative 1. Okay. So the next one is an application. So these applications, we're using quadratics, but rather than quadratic functions, remember for the function application, we were maximizing the revenue, or maximizing the area, or minimum product. That word maximum and minimum were in there, because that's what we were looking for, the vertex, not a solution. Okay? Now we're looking for the value of the two numbers in that equation that we formed. Okay? So different from the first unit, okay, or the second, well, the last unit that we just finished. So two numbers differ by 10, and the sum of their squares is 388. So let x be one number. Okay. Now you could do two variables, but then you're going to have to substitute back in, because an equation only has one. So what you could do is say, if the two numbers differ by 10, so think about, so x minus y equals 10. So if x is one of them, y would be 10 minus x. Put in is there. Okay. Or you could go 10 plus x for the other number. They both differ by 10. Okay, so 10 minus x. Okay. Sum of their squares means equals. So x squared plus 10 minus x squared, that's the sum, means add, squares is 388. Which is different from maybe the sum of their squares is a maximum. And so we would actually say equals m, maybe, for maximum, and then find the vertex. Okay, so expand that out, left-like terms, and solve it. Okay, some bigger numbers here. Always check, can you divide every term by a number? Same number. Right? Is there a common factor to all the terms? So these are all even. So I would divide both sides by 2. Okay, and then you're looking for factors of 144, or negative 144, that add to negative 10. So obviously 1 and 144 is not going to work. 2 and 72 is not going to work. 3 and that would go 48. So you can just use your calculator, do it in your head. They've got to be 10 apart, basically. Is it 8 and 18? Okay, so let's just do this. And then 8. Actually, you would probably go 6 if you were doing these in order. Let me just do that. 2, 4, and 8, and 18. Okay, so those are the factors. One has to be positive, one negative. We need negative 10, so the bigger one has to be negative. your solutions to this are negative 8 and positive 18. Okay, but you're not done. All right, because they aren't 10 apart, right? Those are the x values. So you need to go back, you need to state the two numbers that satisfy this. So there's two pairs, right? So when x is negative 8, then this is 18. Sorry, when x is negative 8, and then 18, numbers, second here, what happens? Negative 8. I put this in here, I would get negative 8 and 18, which is not differing by 10. So, what did I do? It should be negative 8 and negative 18 together, and 18 and 8. Yep. Did I do it wrong? It should be x minus 10. Oh. Oh, it should be x minus 10 is what I should have here. That's all for what? Oh. Okay. Is that what you were going to say? No. Yeah, it's just that in terms of my setup, like, because when you square negative, you get a positive, so that the digits are all good. It's my setup is wrong, because I should have had x minus 10 here. So, don't erase everything. Don't erase everything. I'm just going to go like this, x minus 10. Okay? And then, when I do that, here, this is going to be x minus 10. Does that change this? When I square x minus 10 and when I square 10 minus x, does it change this? No, it's the same. Okay? So then from here down, we're good. This is good. It's just when I go back to substitute it in, right? So now, negative 8 is 1. And then negative 8 minus 10 is negative 18. They are 10 apart. Then when I put in 18, so 18 is 1, 18 minus 10 is 8. They're 10 apart. Okay? So that was my mistake on this part here. Okay? Stupidly, I solved this incorrectly. In any case, we only have to change that one thing there and this thing here. That's all that you have to do. And you can just cross it out. Okay, and then statement answer on your solution. So therefore, the two pairs of numbers are negative 8 and negative 18. And 18 and 8. There's a lot of m's there, so you might want to show it like this. A lot of times. Sometimes we might say natural numbers, so then you would eliminate the negative from your step. Okay? So it kind of depends on the wording, but this doesn't give any stipulation. Anytime there's a squaring, then probably there's two steps, right? Because when you square negative, you get positive. When you square positive, you get positive. All right, and then take a look at the last one. The area of a rug has a central 5 by 3 rectangle in a pattern. So it's like you have a rug in your living room or something in your dining room where it's not wall to wall, so it's a rectangle, and there's sometimes a design in the middle of it. To know the total area, we want to find the width of the border. So this is another common type of question. So just like in quadratic functions, revenue was common, maximizing area, number questions. Here, we've done a number question. Area is common as well, okay? But it's not maximizing it. You're actually finding a particular area or measurement that gives you the area. So an area, so basically I'm going to draw a rectangle. So something like that, and then another one inside. Okay. So here's where the pattern is in this one, right? So it has a central rectangle in a mosaic pattern. So that means inside is 5 times 3. Actually, I'll move that more inside. 5 meters. So 5 meters by 3 meters. Okay, and the inside dimensions. It's got a plain border of uniform width around it. So uniform width means the same width. Not the width of the whole thing. It means this distance here, I'm going to call it x. So this distance is the same as this distance. Okay? So I probably should just make mine a little bit. That's a little better. Okay? So that's the same as this. Means uniform width. Still not perfect, but close. Okay? The area of the entire rug is 24 meters squared. Okay, so we know the inside area, 5 times 3 is 15, but the whole area is 24. Determine the width of the border. Okay, so you can obviously split this into a bunch of rectangles. Right? Here, this would be x times 5 plus 2x, and then this rectangle and this, but that gets really confusing, right? So we want to think about the entire shape here because we know the area of the entire thing. So what is the dimension of the outside? If this is 5 in here and the width is x. Think again. 5 plus 2x. You can't just add them together, right? Yeah, so 5 plus 2x is that. And then similarly here, this is going to be 3 plus 2x. Okay. So the area of the entire rectangle is 24. Okay. You might want to write these down. Area of the inside, we don't really need it. It's 15. But another way of showing this area of the entire thing, we have to get x's in there, right? It's length times width. Okay, and so those have to be equal to each other. So there's your equation. So 24 equals 5 plus 2x times 3 plus 2x. Okay, so now expand that out. Like terms with one side equal to 0. And then factor two numbers that multiply to negative 36, add to 16, that would be negative 18 and 2. You're going to have 2x and 2x as opposed to 4x and 1x. So in this case, you need to check, do both of the solutions make sense? What did I do? Hands go up. Did I? That's plus 9. Oh, yeah, because that's plus 16. Yeah, I did. Thank you. Okay. Okay, so check both of them and see what makes sense. Does it make sense to have a negative width of the border? Any dimension? No. Okay. So this is going to be, we call it inadmissible. It's not extraneous, it's not extra. It's inadmissible because it doesn't make sense for an application question. So the width of the border would be 1/2, and then you have a statement answer, therefore the width of the border, not the width of the rug or carpet, the width of the border is 1/2, and this units here are meters. Okay, or 0.5 meters. If you show it in a diagram, that's okay. But if you don't show a diagram, then yeah, you need a lot space. Last thing I wanted to show you is back when I was a young teacher teaching stuff like this. Instead of putting A entire, I put this. You'll get a little chuckle out of it. So I put the area of the inside, equals, then I put the area of the whole thing equals, and then students started laughing. Oh no. And you're going, what are you laughing about? And then, if you say this too quickly, right, it doesn't sound so good. So then I decided, okay, I'm going to start using the area of the entire thing and the area of the inside. Your recording is still on. Your recording is still on.